Finally, the last feature I'd like to showcase in this module is throwing exceptions during validation. Let's see this feature in practice. We can make Fluent Validation throw exceptions instead of returning a validation result like you can see here. For that, we can use another method in this options class, throw-on-failures. Let me put them on separate lines. Good. Let's see how it works. Removing the email address, and you can see that the library has thrown a validation exception. The exception itself contains the list of errors that took place during the validation. This list is the same as in the validation result. Here it is. Alternatively, we could also use a helper extension method called validate and throw. It does the same thing as throw on failures option, except that it doesn't return anything, which is fine because it throws exceptions instead. And it only accepts the object under validation and not configurations like what rule sets to include. This might be an issue if you have to specify those configurations, and if you do, you need to use the original version instead of this helper method. Let me remove these configurations from here since we are not using rule sets anymore. Very good. Overall, I don't recommend using exceptions when doing validation. Exceptions should only be used for exceptional situations, such as bugs and unrecoverable hardware failures. Validation failures are by definition expected to happen. We will talk more about this in part 2 of this course. You can also watch my course about functional programming for more information about exceptions versus return values. In this module, you saw how to use the Fluent Validation library to validate user input. We discussed various features of this library. In Fluent Validation, all validators are created in separate classes, and all validations are defined in that class's constructor. The validation rules themselves are defined using the rule-for method. The name of the library, Fluent Validation, originates from this style of programming where each method returns an object that you can use to make further method calls. We discussed how to validate complex properties, properties that themselves consist of multiple properties. The best way to do so is to introduce a separate validator specifically for that properties type. This will help you to keep the validation code simple and also allow for using that validator between different API endpoints. We used Fluent Validation to validate collections of objects. Similar to the rule-for method, the Fluent Validation library has a for-each method that allows you to define rules for each item in the collection. Next, we discussed inheritance validation and that it can only be used for validating domain classes, which is an anti-pattern we'll discuss later in this course. We also discussed rule sets, a feature that allows you to combine several rules into a group and then execute or ignore that group during validation. The purpose of this feature is to reuse the same validator class for different API endpoints. Finally, we talked about how to throw exceptions during validation as opposed to returning a validation result. In the next module, we'll talk more about advanced features of Fluent Validation, as well as how to integrate this library with ASP.NET.